This problem is very similar to the gold in the ocean problem, but in this case, you're now looking for the amount of oxygen in the Earth's crust. So it says the Earth's surface area is 5.1 kilometers squared. As you can see, this is the area just like the area of the ocean. And its crust has a mean thickness, so this would be the height. And the density, again, of the Earth. So imagine peeling an orange. That would be the peel. If you lay it flat, that would be the surface area, and the thickness of that peel. So if this is an orange, the thickness of that peel would be the thickness of the Earth's crust would correlate to that, and it would be 35 kilometers thick. And if you lay the orange flat or the Earth flat, then it would have the area of this number, 5.10E8 kilometers squared. Okay. Again, if you can guess, if you multiply these two numbers, this corresponds to length times width, and this corresponds to height. If you multiply the three of them, you would get the volume. Volume is equal to length times width times height. Pause the video and do this problem then. Okay, so the length times width is 5.10E8 kilometers squared. Fortunately, we don't have to convert this because it's already in kilometers. So times 35 kilometers, and we get 1.7. I'm going to go ahead and carry out a little bit more sig figs until, and I'm not going to round until the very end. E10 kilometers cubed. Okay. And the density of this Earth's crust is 2.8 grams of Earth for every 1 centimeter cubed of Earth. So if you imagine taking a little piece of the Earth and put it into a little cube and weighing it, it would weigh 2.8 grams. Okay, that's what that means. It says one of the most abundant elements in the Earth's crust is oxygen. And they gave you that this is the amount of oxygen in the Earth's crust. So I'll use a different color for oxygen and a different color for Earth. So I'll use that color. So this number says 4.55 E5 grams of oxygen. Okay, so this is the density of oxygen now for every 1 ton of Earth. Okay, so imagine you're taking this little cube and then there are dots of oxygen inside it, and I'll use that dot pink, and you're trying to, and in this cube there are a certain amount, right? So if you took a ton of Earth, you would get this much oxygen inside that Earth's crust. And it says that a ton of Earth, a ton means 1,000 kilograms. So that's another conversion factor. Okay, pause the video and try to answer this question with what is given now that you understand it. Okay, so now it says the total mass of oxygen is the question. So I'm going to put that in the very end. It might be long, so I'll do it like over here. So grams of oxygen is what they're looking for. Remembering that all about oxygen is the pink. Okay, so then I don't know where to start with. Okay, so as you can see, I need to know, I can figure out how much oxygen there is if I can figure out how much Earth there is. And this gives me the amount of Earth, the volume of Earth's crust. So now I'm going to start with this number. Okay, 1.785 E10 kilometers cubed. Now, using all the conversion factors, try to get from kilometers cubed of Earth to grams of oxygen. Pause the video. So this conversion right here says I can get to grams of Earth. If I can get to grams of Earth, I can get to tons of Earth. Tons of Earth, I can get to here. So I'm going to convert kilometers cubed to centimeter cubed first. Do that 3 times. And by the way, these are all Earth. Okay. So I'm going to kilometers of Earth. Kilometers is bigger. And I think we did that conversion already. It's 1e5. Because we did that up here. If you remember, kilometers to centimeters is 1, 2, 3, 4, 5 jumps. Okay. So now I'm on cancel the. Oh no, I did this wrong. I should have put the kilometers on the bottom. Okay, let me try that again. So since kilometers on the numerator, I should put that in the denominator. Do it 3 times, it's cubed. Go to centimeter. 111, 1e5, 1e5, 1e5. The reason I know I was doing it wrong because I was about to cancel the kilometers and it wasn't matching. So I'm going to go ahead and now I know I'm doing it right because the units are working out. And that's a big check. When you're doing these problems, keep checking on the units. So now you're in centimeter cubed. I can use something with centimeter cubed. I can use this conversion right here. Okay, so 1 centimeter cubed of Earth, remember this is all Earth still, is 2.8 grams of Earth. Okay, so that cancels with the centimeter cubed, looking good. So now I'm going to go to tons of Earth using this conversion so I can get to tons of oxygen. So it says drop the grams. I'm going to go to kilograms first because that's kilograms. So 1e3 grams is 1 kilo of Earth still. And then over here, 1,000 kilo is 1e3 kilo is 1 ton of Earth. And then over here, 1 ton of Earth has, let me change colors because now I'm going to oxygen. .55 E5 grams of oxygen. Okay, as you can see, I was able to get the information about the Earth, which led me to the information about the oxygen in the Earth, given this conversion. Okay, and I think that's correct. Go ahead and do the calculations, and you should get the answer of 2.3 E25 grams of oxygen.